I had a question about Chapter 8, Question 8b. And what Question 8b is asking is, what is the probability of a score falling above the raw score of 80? And this is a problem where they tell us the mean is 75. And that cuts our normal curve right in half. So that's where our mean is. And it tells us our standard deviation is 6.38. So what you first need to do is calculate your z-score. And to do that, you're going to calculate z equals x minus mean minus divided by standard deviation. So in this one, our x, if we're looking at above 80, we're going to take our 80 minus our mean of 75 divided by our standard deviation of 6.38. So we're going to take our calculator and we're going to take 80 minus 75 divided by 6.38, which is going to get us a z-score of 0.78. And as you can see, we're rounding a little bit. It's 0.783. And in the back of the book, you have a table. And I'm just going to estimate if we're going to draw out our 3 standard deviations, because most of our normal curves should be within 3 standard deviations approximately. So 0.78 is just shy of 1 standard deviation. Okay? And we're looking at the probability that it is greater than that, which is greater than 80. So this is where 80 would approximately lie, and we want to know the probability of it being greater than that. So if you look your z-score up in the back of the book on page 368 and 369, we have a table that gives us the area beneath the normal curve between the mean and the z-score. So what that's going to do, and I'm just going to write this in red, is it's going to give us our area between our mean and our z-score. So this spot here is our z of 0.78. So z equals 0.78, and that's that line right there that we drew in. Okay. The table on pages 368 and 369 gives us the area between the mean and the z-score. So we're going to look up 0.78 in our table. And that gives us a probability of 28.23, which is the same as 0.2823 if we're looking at probabilities. But basically that tells us that about 28% of our data lies between our mean and our z-score, which is this area here in red, okay, between those 2 arrows. We need to find the probability that it's actually greater than. So we need this area in black here, and only that. So the first thing we need to do is figure out what's not shaded, and then we can easily figure out what's shaded. So I'm going to change colors here. If I look at this area here in green, this is my mean and to my left of my mean. Well, if I think about it, in a normal curve, everything on either side of my mean accounts for 50% of my data. So the area shaded in green is 50% or 0.5 of my data. Okay? If I take my 0.5 and add it on to my 0.2823, so I got 0.5 plus 0.2823, okay, which equals 0.7823, okay? That 0.7823 is everything from my z-score to the left, okay? So that represents about 78% of my data. We need to know that area shaded in black, and to do that, we need to take our total score here, which is 1. When we do a normal curve, the normal curve equals 1. And I'm going to subtract the area that was originally in white, which is this whole area to the left of my z-score. And that was at 0.7823. When I do that, I'm left with about 0.2177. So that tells me this area in black here is about 21.77% of my data, and that answers the question posed in the book.